Hello, my name is Aaron Schoelkopf, and I'm a senior in civil engineering at Colorado State University. The first thing I'll be talking about today is a feasibility paper I wrote not too long ago, where I interviewed three students, two from Fort Collins and one from Boulder, to see if it was feasible for them to grow their own crops while in college. But today we'll be talking about diffuse and non-diffuse pollution, and we'll be focusing a little more on diffuse pollution, and in particular agricultural diffuse pollution. So we'll begin by understanding what diffuse pollution is and how it's different from point source pollution. So another word for diffuse pollution is non-point source pollution. And what non-point source pollution is any kind of pollution that's in the environment that is really hard to monitor, hard to track, and it diffuses itself throughout the environment. A point source is something that you can physically point at, a pipe coming out of a water treatment facility, something being discharged directly into a river. That has a point source where you can look at it and monitor the concentration of whatever's coming out. So now we'll talk about the sources of non-point source pollution. So a lot of sources can be, as I said, something that's diffuse, something that's hard to track, hard to monitor. This can be from urban sources such as wear on your tires, oil leaking from your car, oils on the pavement, anything that gets washed down the storm sewer drains. This can be mine drainage from a mine exposure. This can be from agricultural sources like adding nutrients to your fields, fertilizers, not managing animal waste well. It has a lot of different sources. But the way that these sources are calculated, it shows that agricultural sources input more than 41% of these non-point source pollutions. And these are very difficult to track. It is also shown that over 65% of pollution in our surface waters is due to non-point source pollution. But today we'll also just mainly be talking about agricultural contribution to non-point source pollution. So to more understand that, we'll talk about how this diffuse pollution moves through the environment. So when we'll use the example of a farmer. When a farmer puts nutrients onto his crops, mostly usually nitrogen or phosphorus, not all of these nutrients are absorbed by the plant. They're transformed throughout the environment into different forms, and when they become aqueous, which means they are dissolved in water, they can move with the water and the movement of the water and ultimately end up in places that are much far away from where the point of contact of the nutrient was applied. So this is a natural process where nutrients move around throughout the environment, but what humans have done by having large-scale agricultural operations is they have large nutrient loading problems now. So off in the Gulf of Mexico, all these nutrients from the Mississippi River basin are collecting into the Mississippi River and being transported as aqueous solutions into the Gulf of Mexico. Now, once all that moves into the Gulf of Mexico, we have a bigger problem because then algae take that excess nutrients. In particular, their limiting nutrient is phosphorus, and the limiting nutrient just means that without it, it wouldn't be able to bloom. So these large algal blooms start to form, and they block out the sun for other photosynthetic organisms. Those other photosynthetic organisms can't oxygenate the water. Then when the large algal blooms die, they sink to the bottom of the body of water. They die, and when they're being decomposed, that takes a lot of oxygen as the mechanism. So it depletes the water content, and right now we have a hypoxic zone in the Gulf of Mexico. And a hypoxic zone means that the dissolved oxygen content of a water body is less than 2 parts per billion, and that is not enough to sustain aquatic life. So that's a bit about the issue that we're facing with diffuse pollution and how it's a little bit different than point source pollution. You have so many resources at your disposal if you would like to look more into this, and I really encourage you to, because as environmentalists, it's really important to know how pollution is divvied up, where it's going, how it's transformed in our environment, where the nutrient loading happens. And it's just really important to be educated about these things. And the EPA, the NCRS show a lot of great resources about where the diffuse pollution comes from, how to mitigate it using BMPs, which are best management practices, stories of success from people who have been conflicted and have had issues with diffuse pollution. They have computational tools for if anyone's interested in using something like that. They also have a discussion forum, so you can ask people about questions about how this works, or if you have land or something that you want to know, make sure you're not contributing too much diffuse pollution, or if you have something like a body of water that is being impacted by diffuse pollution, you can talk to people about this. They also have monitoring programs if you need to be monitored, and webinars. So I urge people to look into this, and I'll leave you with one final thing to think about. The hypoxic zone in the Gulf of Mexico is currently at the smallest it has been since it's been monitored. So I'd like to leave you with a question of saying, do you think that we have started to use better management practices, or do you think that maybe climate change, or just a change in the change in the climate, has influenced the way that the algal bloom has grown? Thank you for watching. Have a great day.